Now, some of you might have seen that a project that we were involved in at Existor was, so that's my company, I'm working with the business department, etc., was a thing called 221B for in promotion of the Warner Brothers film. And I'm only putting that up because I'm going to use a funny example that might seem strange if I didn't. Anyway, the game lets you become Holmes or Watson, and you can interview crime suspects or witnesses to a crime, and ask them what they know, etc., etc. And the number of things that these bots can say, unlike my learning AI, is very limited. But the number of things that can be said to them is huge. And as you'll see, it was a reasonable challenge to respond to questions like this. So tell me, was Lord Shurston's daughter's lover having an affair with the victim? Now, that's, you can imagine coding that in a normal way, etc. Of course you can. But imagine the number of variations that are possible on that sentence. They're simply enormous. If you... and I'm afraid I'm not going to today be showing the actual construction techniques, the ways we put together these phrases. But there's no grammar parsing involved at all. It's about patterns. It's based on breaking up sentences into, or the meanings of sentences into components, into these phrasal components. And it's about predicting what people will say in a given context. So we expect someone this point in the interview to say, to ask a question like this, and therefore, when we have a response to it, of course. Looking at that example, looking at the end of it, it's clear that the victim might be the murder victim, or the dead girl, or it might be the name of the person. But it will have more variations than that, because that person could also be someone else's child. That person could also be referred to by a whole subclause, such as the woman who was killed. And within that subclause, the word killed could be murdered or slain, etc., etc. Everything within each other. It gets huge, the number of variations that you're dealing with. And again, we're dealing with the whole sentence. We're not just picking out labels for different little bits of it. We're constructing the sentence in the computer's head, if you like, and then seeing, after the event, seeing which one it was most close to, which of its predictions as to what the person would say it was really most close to. Even more clearly than the previous example, the Lord Shurston's daughter's lover is highly recursive. And so you can have additions to that sort of a list at multiple levels. So at the level of the complete thing, it would be the name of the person, let's say, who was Hugh. But equal to Lord Shurston's daughter would be her name, etc. And many other ways of referring to her. She might be a nun, or she might be, etc., etc., etc. And in fact, for things like that sequence of logic there for the Lord Shurston's, etc., etc., a special protection had to be put in to avoid it thinking in circular fashion, so that you look in a relationship of several people and you start going around in circles, and everyone, you start ending up with a stream of infinite length, etc., as the recursion gets too great. Anyway, so one thing I was saying was that this is equal to that, Hugh is equal to this person, etc., etc. But actually it's not all about being equal. It's called equivalence, but you can determine the degree of equivalence or belongingness to any given set. So you can essentially give a percentage where you say this word. So there might be an obscure way of referring to having an affair, let's say. And that might be ambiguous, so it might mean something else altogether. So you might add it to the list for having an affair at a 50% accuracy or something like that. So that it only belongs to that list, only a certain amount. And that helps also to disambiguate when you're handling conflicting interpretations of the same input. So I mentioned that data can be extracted, but it allows mapping of one thing to another. So this Lord Shelton's blah could return the word hue into a variable called him, and then that him could be used as a context in future. So when you next input, you might refer to this person as him, and because you have referred to this person already, it will understand what you mean, etc. And finally, on this example, at a higher level, because we're working at multiple levels, you might have a phrase that determines the complete thing, the complete clause or sentence. That was for was X having an affair with Y, with variations with reversed orders and all sorts of things. X was intimate with Y, or you might have was Y in love with X, etc., the other way around. So the patterns occur at any number of levels, and if you wanted to take this sentence and include it with another sentence, so you're expecting somebody to put in two questions next side by side effectively in one input, you could just pick up that phrase for the whole thing and put it side by side with the next one. So you've probably already got the point that I'm trying to make on a larger scale. When handling this prediction space, these constructions of these variations, the number of variations that you can create is gigantic. It's in the billions. It's in the billions, or trillions is only one multiple away, because it's all about a combinatorial explosion. You've got the list of variations for this part of the sentence multiplied by the list of variations for that part of the sentence multiplied by that. But that's a really simple sentence where you've just got one block, another block, another block. In reality, in an example like this, you've got a block within that block and another block within that one that's within that, etc., etc. So the multiples get enormously greater very, very quickly. And computing-wise, it's simply not possible to literally put all of those in the brain of the computer, if you like, in its memory, and then see whether they match what you've input. Because you're dealing with trillions, you explode the computer a long time fast. But so it has to kind of feel its way in a more sequential fashion, left to right, etc., as the sentence is being formed. So in a similar sort of way, yeah. I am completely there. Anyway, the result of this is that if you have the people and the time and the resources to create the content for the scripting, it's possible to understand just about any sentence in the English language. Understand it in the sense of you know exactly what it means. You can then cause, you, the creator, knows what it means. You cause it to go down the right path next. You cause it to do the right thing. And even though the content creation is a problem, the time spent creating the content for this, for business communication, etc., there are plenty of cases where there is domain-specific knowledge that you can really genuinely use it all, create enough data. So thank you.